Okay, so any prime number greater than 3 is always 1 away from a number in the 6 times table. How can we prove that using algebra tiles? So here's my multiple of 6. And you can see it's in the 2 times table because it's 3n times by 2. And it's also in the 2 times table, it's 2n times by 3. But if I add 1 to this, and now we're talking 1 more than a multiple of 6, this expression here no longer factorises. So there's a possibility that this number here could be a prime number. But if I add 2 to it, then think about adding 2 to any number in the 6 times table. It will always be another even number. So it will always factorise into 3n plus 1 times by 2. And likewise, if I add another number to it, so now we're talking 3 more than a multiple of 6, then this one's always going to be in the 3 times table. So you can see we can always factorise this into 2n plus 1 times by 3. Okay, what if I add a fourth number then? So we're talking 4 more than a multiple of 6. Then we're back to even numbers, aren't we? Think about adding 4 to any number in the 6 times table. So that will always factorise, and it will always factorise into 3n plus 2 times by 2. Okay, but what if I add a fifth number then? So adding 5 to a multiple of 6, now we're 1 away from a multiple of 6, and this expression here will no longer factorise. There's no way of making a perfect rectangle from these tiles. So here's another possibility, 1 away from a multiple of 6, or 5 more than a multiple of 6, could potentially be a prime number. And then adding our final 6 tile, we then reach the next multiple of 6. So the only 2 possibilities where we could have a prime number is 1 away from a multiple of 6, like this, or when we were 1 greater than a multiple of 6, like this. All the other options factorised, so they couldn't possibly be prime.